Okay, fine. So, okay. Hello, everyone. Good afternoon. Welcome to our first live session of this NPTEL course named Introduction to Dynamical Models in Biology. This is a 4-week course, and this is our first live session. We are already in the second week of our course. You must be following the video lectures, going through the assignments. The first week assignment deadline is reaching very soon in this week. So if you have not submitted your first assignment, please remember to submit it in time. So let's discuss about today's agenda. What we will do, what we will discuss in today's class, right? So what we will do is that we will discuss primarily the topics of first week and second week, the key point that we are supposed to remember, supposed to pay attention to. And then the second thing is we will discuss about certain queries that you may have. Also, what I will do, I will go through some numerical problems. Additionally, apart from in assignments, you have lots of numerical problems. So additionally, there are some problems in the video lectures also. But additional some problem I'll discuss those, how to solve them, some interesting one. And at the end, what I will do at the end of our discussion, I will discuss about how you should prepare for the final examination, right? So if you have registered for the final examination, please stick to the end of this live session, because the last part of our discussion would be on how one first should prepare for the final examination. So let me start with my the first topic, that the key points of the first week's lecture. In first week lecture, we are actually preparing the ground for dynamical. If you really understand, you must have already got the flavor of this course. In this course, we are trying to create mathematical model and analyze those models that captures the dynamics of biology. And that dynamics can be in different scales, right? There can be dynamics in ecology, there can be dynamics inside a cell. For example, gene expression, one more transcription factor comes and binds to the promoter, and that induces production of mRNA. From mRNA, you have production of protein by translation. This is a dynamical process. You may want to create a mathematical model. On the other hand, if you go to the higher scale, where the species are interacting, in the ecological niche, one species may interact with 3 other species, and they may have some predator-prey relationship. Based upon that, you may want to create a dynamical model that how their population will vary in time. So these type of problems we want to handle in this course. And as it's an introductory course, we are sticking to only the fundamental aspects that are required for you to jump into this type of subjects. And as we have always said that you must be aware of systems biology. Systems biology relies and stands upon a very old area of scientific endeavor called dynamical systems theory. Dynamical systems theory is based upon this type of dynamical model, mathematical model based using ordinary differential equation and partial differential equations. In this course, as it is an introductory course, we have not dealt with partial differential equation. We will only deal with ordinary differential equation. So let us look into the first week main content and the point that you should keep in mind while reading it, right? So the first thing is the first lesson that you should learn in the lectures of first week is that, see, mathematical models are not real. No, mathematical models is a reflection or a reduced version of what you are seeing in real. So if you want to create a model, you do not want to include everything that is happening in reality, but rather you want to create a very reduced representation of the whole thing. Just like a map does not represent, suppose I want to draw the map of IIT Guwahati. So that will not be real IIT Guwahati. That will be a reduced representation of IIT Guwahati. Similarly, our mathematical models are reduced representation of real systems. So you have to create a very simple, at the same time meaningful and useful mathematical model. So in the first week's lecture, we want to give a flavor of. Now, after that, we enter into ODE-based modeling. So in this lecture, if I remember correctly, in the second lecture, what you have to do is that you have to understand what is ODE, what is partial differential equation, what is a linear ODE. You have to also understand what is a non-linear ODE. And also, if you have done class 12 level calculus, you must be aware of this thing. But just to recapitulate those topics, you have to also know the order of ODE, right? First order, second order. These basic mathematical concept we are discussing in the second lecture. So if you have gone through it, if you have any calculus book with you in your book cell, please go through them to these basics, because these are fundamentals that we should remember while doing this course, right? And also in exam, sometimes we ask, okay, identify is this a linear ODA or a non-linear ODA? Or suppose we ask, give an example of non-linear ODA. Give an example of second order ODE. So you should be able to answer. Beyond that, one very important point has been discussed in the first week's lecture. That is when I can use ODE based model. This is very important. All ordinary differential equation based model that we use in dynamical systems theory are based upon two key assumptions. What are those two assumptions? One is the system is homogeneous, it's well mixed. If the system is not well mixed, then I cannot use ODE. That has been discussed in the lecture. I'll just remind you again, if it is not homogeneous, I have to use partial differential equation. So if I am using ordinary differential equation, that means I'm assuming the system is homogeneous. And the second point is the system is very large. The number of molecules should be high, that means their concentration should be high. If you are creating a population level model, then the number of individual, number of people infected with the disease, number of animals in a particular niche, number of tree in your garden, if these are your variable, then that number has to be very large. For a small number, we cannot use ODE based approach. So these two important points are there in our second week's lecture. Please remember these because these are very critical things, and in many exams and quiz we usually ask this question based upon these 2 points, that your system has to be homogeneous and the system should be large. Then you should focus on law of mass action. I am sure all of you know law of mass action. Somewhere in class 12 or in chemistry in graduate level, you must have studied it. But it is usually, as we do not use it regularly, we forget. So in this course, second week, we have introduced it. In this first week, we have introduced it in a lecture, right, briefly. So please go back. If you have a textbook, you can look into it. Otherwise, look into the lecture slide. We have explained what is law of mass action, and you should be able to write differential equations, rate equations based upon law of mass action. It's a must. You have to learn it, right? I believe you know it. Just to recap, just go through recapitulating, and you should be comfortable of writing ordinary differential equation based rate equation using law of mass. Then one important point here: if you are already online through Teams or in the YouTube, if you have any query at any moment, please raise your hand or post a question here in the chat, right, so that we can understand. In YouTube, you can directly type on the chat with your question. Or if you are join through Teams, please raise your hand. Then I'll ask you to raise the question. Right. Now, one important thing I will remind you again at the end of this lecture also, but let me tell you here itself, is that, see, this is a self-contained course. So I do not recommend that you have to go and read hundreds of other books. But you have to follow each of the lecture slides, the simulation codes very religiously. So in this first week's course, we have multiple mathematical models. We have one model for disease spread, right? Please go through the model. Find out the reasoning why we are writing a particular type of ODE. Try to solve those ODE analytically by integration yourself. Just don't blindly follow the video. You try, paper and pen, you try to integrate the equation and do it. Because remember, That is important. In exam, in assignments, we are asking you to do small problem where you have to do integration yourself, right? So you practice that using the models that we are discussing in first week. Similarly, there is one lecture on population growth, right? Population model. And in that lecture, we have introduced logistic function, which is used widely in dynamical systems in biology. Not just in population model, from gene expression to ecological model, everywhere you find use of logistic function. So what is logistic function? You should be able to answer that question. What is the behavior of logistic function? If I draw x versus fx, and fx is logistic function of x, then how should be the behavior of that one? All these things are discussed in our lectures in week 1, right? There is a particular lecture where we have discussed this. Don't miss that. Follow that, try to understand those, and also try to integrate those. Then comes one important rule. Remember that most of the models that we will build in real life, and if you look into new journal papers or books or research articles, you will find most of the models that we build using differential equation are so complicated, so nonlinear or large that you cannot actually analytically by integrating solve them. So all of us throughout the world rely upon numerical solution. We use computers to solve our job is to write down the OD, and then we use a programming language or some ready-made tool to numerically solve those, or in other words, simulate those. So how do we do that? One almost 300-year-old method is called the Eulers method, and in first week's lecture, I have discussed thoroughly, step by step, how to implement Eulers. Eulers method is very old, but it's very easy to understand and very easy to implement even by paper and pen, right? So what I will insist, please practice solving ODE using Euler method by paper and pen. Take a simple ODE, any example, right? We have given an example in the presentation, right? In our lecture, you try to do these, creating a table. I have shown that in the lecture, step by step practice, right? Because we expect somebody who has done this course should be able to implement Euler's method by paper and pen, and if required, they may go and in future write a code also to implement that. Although ready-made library functions are available for Euler's method almost in any language. You start from C to MATLAB, every right. Now after that, we have discussed about Runge-Kutta method, which is a higher version, modified version, more efficient version, and more accurate version, accurate method of solving numerically a differential equation. I have gone through details of it. You should go through it, but you have to understand the essence of it. You have to understand the difference between Euler's, right? And you have to difference between the Runge-Kutta methods. That is, remember, you will be user of this today. You will not develop this thing, right? So you have to understand what is the difference between. For example, Runge-Kutta method is more accurate. Why it is accurate? Because it uses multiple slopes. These type of questions you should be able to answer. You should have a clear idea. And then I discuss about the effect of step size, which will affect both Runge-Kutta method as well as Euler's. These part you have to understand. Because step size problem you will face every time you will doing numerical simulation in real. So you should have a very clear idea about how step size in calculation can affect your results, right? And at the end, we have discussed about adaptive step size. Please go through that algorithm step by step. It is discussed and explained. You should understand why adaptive step size is used and what is the advantage and disadvantage of it. So that's all in week 1. Fine. That is all we have in week 1. These are the key points, and you should actually focus on these key points when you are going to the lectures of week 1. Now let me go to week 2. If anybody has any query, can raise it here. Okay, so in week 2, what do we have? The first thing, already week 2 material is available. Videos are online. The slides are also available. You can download them. The most important thing that you should learn in week 2 is how to use JSIM. JSIM is a simulation software. When you learn this dynamical systems theory in details, when you are habituated with programming in C, Fortran, or MATLAB or Python, you can use those programming languages to write custom code to solve your particular differential equation based problem. But for rest of the people who are not much acquainted with programming languages, JSIM can be very useful. And that's why I have chosen JSIM, because JSIM gives the flavor of both the same. It has a GUI, you just click switch and the thing runs, you get a data, you can get the diagram, you can get visualization, everything very easily. At the same time, it also allows you to write down the model, write a computer code, write a program. So you have to define the model using math, a particular language. And then you have to simulate with JSIM. So it is a mix of both programming as well as use of ready-made software. So people who are not habituated much with programming languages, they find very easy to use it. And people who are habituated to programming also, they also find it very interesting to use. So this is a balance between these two. That's why I insist on JSIM. The link to download JSIM is given in the portal, even in the slides that we have. Remember, JSIM has changed its web page. It was earlier in a different website. Now it has changed. So the changed web link is given in the portal and also in the slides that you can download from our portal. So follow that link, install JSIM in your machine, right? That's how you should start. Second week course means you install JSIM, and then we have a lecture on basic use of JSIM, basic steps, elementary steps. Follow them. You will easily learn JSIM. JSIM has a very easy learning curve. I believe you can easily learn. And then every lecture where we will have different simulation, will provide you the code also that I am using during the lecture. You can download that code, copy paste that in JSIM, run it, edit it, play with it. Remember, to learn simulation is always to break an existing model, modify it in your own way, and see how it behaves. But please practice. Okay, I think we have a question here saying that. Give me a minute. Yes, Balaji has asked a very important question. In final exam, do you have access to JSIM? No. In final exam, you will not have access to JSIM. So I will not ask you to simulate, some problem, some model using JSIM. No, that will not be asked. But prepare yourself to answer questions based upon JSIM. What do I mean by that? You will not have access to JSIM. But if I give you a JSIM code, you should be able to read and understand what should be the output of that code. Right? That type of question. I may give you a JSIM code block, a part of it, and ask you, find out the mistake in that. That type of question should be. Right? You should prepare yourself for that type of question. Because we want you to learn this. Right? So if for that you do not need the JSIM running in your machine at that time during examination. If you know JSIM, you should be able to answer this type. So that means learning JSIM for this course is essential. For the exam as well as to enjoy and understand the whole course, it is always better that you simulate yourself and see how the model is made. So I hope Balaji, this answers your question. Next important issue after JSIM, which is in this second week, is that the understanding of steady state, the definition of steady state, and the stability of steady states. We discuss the issue of steady state and their stability in 2 parts. First, we take one-dimensional problem where I have only one OD, and then we introduce you to direction. Right? This is what I have written, direction. And then in this, while discussing direction field, we discuss about steady state, and stability of states, like stable steady state, unstable steady state, semi-stable steady state. All these concepts are discussed, and also a mathematical method is given. A very simple mathematical method is given, discussed, by which you should be able to specify the stability of a given state. Please practice that. Very easy. Paper and pen method, you can very easily do that. Use that. Learn that. Lots of ideas will get clear to you, as well as at the same time, you will be ready for the exam. Then once we are done with 1D, we go into 2D, where we discuss about page portrait. Again, in two-dimensional case, we explain what is steady state. Then we discuss the stability of steady state. We also discuss very important point here, which is not present in 1D case. It's called the null clients. Null clients, if you have seen already the course material for this week, second week, you must be aware that null clients are curves or lines on which the derivative is 0. And by intersection of null clients, we can identify the steady states. This one is also something which you should practice yourself at home. If a system of OD, two ODs are given, two coupled ODs are given, like for example, this is something like this, dx dt equal to function of x, y, arbitrarily I'm writing, right? And dy dt equal to another function of x, y, something is given, draw the null clients. Practice, write an arbitrary function and try to get the null client. Follow the video, step-by-step instruction is given how to find the null client and find out how the null clients are intersecting. What are the steps? These you should be very clear. And also, there can be different types of page portrait for two-dimensional systems, 2D systems, right? We call them sink node, source node, spiral sink. All these are discussed in our lecture videos. Please go through them, try to understand them. At any moment, if you find at any of this topic, if you find it's difficult to understand, drop a message in the discussion forum. If you are not very comfortable to discuss your questions on the discussion forum, you post a question to me directly to my email. There is no problem. We will try to answer the question. But go through these, try to understand them. And as I have said repeatedly, you don't have to go and search into hundreds of books. We have given references for some online books. If you are an advanced student, you can always go to look into those books. But otherwise, to learn this fundamental that we intend to teach you in this course, you can easily understand and learn from the lectures, the slides, and the simulation model, the chasing model that we are providing. Practice those, you'll be able to answer. Right? Any question after this, after the second week? Okay. If there is no more question, then let me go to the discussion where I will pick up few problems. Right? You have already seen some problems in the assignments. So from that you must be getting the flavor that what type of question that we expect in the final exam also. So this is the problem, a very simple problem. Let us start with a very simple. What we are saying here is that degradation of a protein is actually depends proportional to, this is important, proportional to the current concentration of the. I hope you can see the question here. And I am asking you that there are 4 options given. Which of these differential equation is the correct one to represent the degradation of this process, where only protein is getting degraded? Right. So we are not bothered about protein production. So we only want to capture the protein degradation. So which of these 4 will be the correct answer? Does someone want to try? Give the answer. You can raise your hand or write on the chat. We have 4 options given here. We have said that the degradation of protein is proportional to the concentration of the protein at that time. Which of these following ODE is the right model for this degradation? Is there anyone who can try? Yes, one answer Christian has said B. Yes, absolutely correct. B or 2. Actually, I hope you are saying 2. This one, right? I hope that is what you have written when you say B. That is the second option. Yes, absolutely correct. See, a differential equation in the first week's lecture we have said differential equation is used to represent the rate of a process. In this case, the rate of the process is dp dt. Now all these 4 options has dp dt. Fine. Now I will look at the right hand side. The first important thing, by degradation, what is happening? The amount of the protein is decreasing. That means I should have a minus sign here. Okay, I have 2 options where I have a minus sign. Now I have to differentiate between these 2, the first option and second option. In the first option, it is K by P. P is the concentration. So it is inversely proportional. So obviously it cannot be because the question says it is proportional to the first one. Sorry, the proportional to the concentration. So it must be this one, the second one. dp dt is minus K into P. And this is typical what you may have learned in chemistry textbook, the kinetics of reaction. This is first order T. As simple as first order T. I have not done it here, but you should be able to integrate it like this, like dp dt. You take the P here, P on this side, right? So then it will become minus K into T into dt. Then you integrate both the sides. And you should be able to get the equation of the time evolution of P, how P will decrease with time. And if you do that, you can immediately easily see this is the first order decay that you have done in chemistry class, right? And you can calculate also the half-life of the protein and everything you can. So practice this type of problem. I just want to instigate you, trigger you to try this type of problem, right? And now let me go to the okay, somebody has said that D is the correct answer. D is not correct answer because notice the sign before it is positive, right? So that will be the production, means P is increased, but in this case it is degradation. So protein is getting used up, right? We are losing protein. So that means it must be minus. Right? Okay, let me take the second question. This is very interesting. See, whenever we start modeling something, most of the time we try to create a what we call graphical model. And if you are a biology student, you are habituated with graphical model. You open your molecular biology book, you open your biochemistry book, you see those diagrams, right? Very complicated cell signaling pathway. We try to represent them by arrows, molecules connected by arrows. Or you think about metabolic network, right? You have different molecules produced, then you have feedback control. All these things you represent diagram because that helps us to understand the process. The same thing. Many a time when we want to create mathematical models of a process, a cellular process, suppose, we try to draw a picture, graphically represent the process, all the variables, who is controlling. This is called a graphical. So a graphical model is given, right? And you have to find out where is the mist. So what we have this outer ellipse. So this is one compartment. This may be representing the cell. Then you have inside another ellipse. So that may be representing another compartment within the main compartment. And A, B, subscript C, B, N, B, C. These are different molecules, right? So you can say A to BC is formed, then BC goes inside the second compartment, that is BN, and then BN comes out as BC, something like this. So you have to find out where is the mistake in this graphic. So I'll wait for 1 or 2 minutes if somebody want to answer where is the mistake in this model, in this graphical representation. Options are given here and zoom in. there is no need to show two compartment. That is the first option. Second is BC should be shown only once in the same compartment. Yeah, BC has been shown twice actually. The third option is there is no need for two names for B. We have two names, BC and BA. And the fourth option is the arrows are meaningless. So which of these four are actually the mistakes? Okay. One answer I have got in YouTube is C. There is no need for two names for B. Okay, I'll wait for some other answer. Let me see. Is there anyone? Okay, there is no other answer. So, okay, Mohita has said B. Okay, so we have two. Two learner has given two answers. One is C, one is B. Okay, let me tell the answer. Yes, B is the correct answer. B is the correct answer. C is not correct. Why? Let me explain what is happening. See why I have written this, created this graphical. Because I want to write down the OD. So for every variable that is changing with time, I should have a OD. So what is happening? From this diagram, what I can understand that BC is actually model of a cell. Inside the cell, there is another compartment, possibly that is the nucleus. So what is happening here is that A is getting converted into B, B is entering into nucleus, and then again coming out in the cytoplasm. So that's why these people have used C. C may be representing cytoplasm, 2 as a subscript, and N as another subscript. Now, why I am doing this? The first thing is see. First question, is there no need to show two compartment? No, I have to show two compartment because what we are trying to capture here is that A is becoming B and that B is entering into the site nucleus. So if I have to keep a track that how much B is in the nucleus, I need to imagine a compartment. I have to consider a compartment. So the first option is not covered. I have to consider a compartment. The third option, there is no need for two names of B. No, I need it because if I only use B, then how I will keep track of how much is in the cytoplasm and how much is in the nucleus? Because if I have to keep their track separately, that means I have to use different name. A BN for the nucleus, BC for the cytoplasmic. Then I can write dBc dt. So this will be the dBc dt is the rate of change of B in the cytoplasm. dPn dt will be the rate of change of B in the nucleus. If I club them together, then all are lost. So I cannot keep track of them separately. So that means I need two names. The fourth option, arrows are meaningless. Obviously, they are not meaningless because without the arrow, how will I know the story that A is becoming B, B is becoming going to the nucleus? How will I know? So arrows are not meaningful. We need the arrows. Now look at the correct option B. BC should be shown only once in the same column. The problem is what we have done. See, I will write a ODE for A. So DAD2. I will write a ODE for this BC, which is created from A. I will write a ODE for BN. So now this BC is separately shown here, which is coming out of BN nucleus. Do I have to separately track it? No, because it is coming back to the cytoplasm. So I should consider as a part of the cytoplasmic B. If I consider it separately, then I have to keep a different track. But that is meaningless here because the molecule B has entered in the nucleus. From that, again, it has come back as B to the cytoplasm. So these two are same thing. So there is no need to show the same thing twice in the same column. Right? So we should not represent the same variable, same molecule, same person, same animal, same cell in the same compartment twice. Only once is good enough. Otherwise, we cannot keep a track. Is there any confusion about this? I hope not. Okay, let us go to the some other problem, right? Okay. This is from the second. If you have already discussed about, you have gone through the lectures of second week, you should be able to answer this very easily. What we are doing here, we want to calculate. The question is calculate the steady states of the following ODE and comment on their states. State. So this one ODE is given. I have to calculate the steady state and find the state. So how should I know? Let me do it. Many of you may be already aware how to do that if you have seen the lectures. So steady state means, what do I mean by steady state? In this case, a derivative will be equal to 0. So I put x square minus 9 equal to 0. So now I have to solve it for x. So I can say that x is, plus minus 3. The solution is plus minus 3. That means this system has two states. One is plus 3, another is minus. This is a test problem. So in this case, we can always consider positive and negative both the values. But remember, when we will create a real life model, for example, model for a biological problem where molecules are involved, or population of animals or humans are involved, or we are dealing with cells in our model, then negative steady state does not make sense. That we have to keep in mind, right? In that case, we will take the positive steady state, but it's a generic problem, so both are accepted. So I have two steady state, plus 3 and minus 3. So now the second, I have to check the state. So in one lecture, I have explained how to actually find the stability of a steady state for a one-dimensional system very easily using a tabular. So what is that? The method is, I'll draw this type of thing. In the middle row here, I write x equal to the one of the steady state is plus 3, right? So I write x equal to 3. In the second column, I calculate dx. So when x equal to 3, if I look into my ODE, x equal to 3 means dx will be 0. That's true because it's the steady state. So I draw an arrow like this. That means if I am in this steady state with time, I'll move like this. I'll stay at that space. Now, above this x equal to 3 row, the middle row, on the top row, I will take a value slightly bigger than x. So, slightly bigger means it will depend upon you how big you will take, but take it judiciously. In this case, I will take 4. So, if x equal to 4, then what is dx dt? X square minus 9 equal to dx dt. So 4 square minus 9, it will be a positive value, right? I will not also calculate, right? It will be a positive value, 16 minus 9. So positive value means my arrow will be pointing up. Right? And I will take a smaller value than x equal to 3, the steady state, in the lowest row. So let us take x equal to 2. So in that case, x equal to 2 means 4 minus 9 in minus 5. So it's a negative. So my arrow will point towards this. So that means x equal to 3 is unstable. Because I am in steady state. If you at x equal to 3, if you disturb me, I will move up. That is what this arrow is saying. If you disturb me, I will move up. If you pull me down from that steady state, I will go away from it to the down direction. So from both directions, I will move away from the steady state. So it is unstable. Now let us do for the second. X equal to minus, same thing. x equal to -3. Dx dt will be 0 because that's a steady state. My arrow will be horizontal. Now, one important point. Over the year, I have seen people do mistake here. See, on the top row, I have to take a value bigger than this steady state value. So I will take x equal to -2. So again, my dx dt is x square minus 9, right? So if I put -2 here as an x, I get +4. +4 minus 9 is negative value. So I like negative. That means my arrow should point towards the steady state, lower. And the lowest row, I will take a value lesser than the steady state. So steady state is x -3. So I will take x equal to -4. So let me plot the value of -4 for x. 16 minus 9 is a positive value. So my arrow should point like this. Right? So in this case, what we have, I have the steady state, and both the arrows from top and bottom are pointing to the steady state. That means this is a stable steady state. If you disturb me from the steady state, and pull it down or pull me up, with time I will again come and reach and collapse on the steady state x equal to -3. So this is a x equal to -3 is stable state. Fine. This is a method very easy to use. Please practice it. Please practice it by paper and pen, and you should be able to do it. Only problem, only mistake I have seen people that on the upper row, the value that of x that you will consider should be bigger than the steady state, and in the lower one it should be lower than the steady state. Don't swap this. If you swap them, then all your conclusion will be fine. Now let me change. Stop this presentation and I'll show you something else. There are, see, in the second week, we are actually discussing about direction field, page portrait, and all this, right? There are some, I always insist that you try to draw them by hand, practice them, but at the same time, there are lots of nice nice online tool to actually visualize direction field and page. So let me share my screen and show you one such. I always recommend people to go and use them. So this is, if you can see my screen, right? This is a direction field plot. You can search in any search engine. You can search the direction field plotter, online direction field plotter, or vector field plotter. You will get this plotting. I'm using one. I hope you can see here. So what I have done, I have defined the equation here, the ODE. Just now we had dx equal to x square minus 9. So in this case, they are defining in terms of y. So I have written y square minus 9. Fine. And then you have something, minimum time, minimum y, maximum y. I have kept them default -5 and all this. You can change them based on your requirement. And then you click this one, graph the direction. And it is plotted. You can see. See, remember we have two steady state. One is +3, another is -3. So if I click on this +3 line, just above it, you see, we say +3 is unstable. So all just above +3, my trajectory is running away from that +3. If I start just below it, I will go down. And where I am collapsing, you see, I am collapsing on -3 because -3 is my stable state. So if I start somewhere just below -3, again, I will collapse on the -3. So in this direction field, the arrows are telling me if I start from one position, where I will reach. If I start somewhere at 1, at t equal to 0, I'll go back and collapse in -3 because -3 is my stable state. Similarly, for two-dimensional system, we have discussed in lecture. Please follow the lecture and then use this phase plane plot. Right? Phase plane plotter is for two dimensions. One dimension is for X, another dimension for Y. What you do, you plug. For example, one example is given here, right? So dx is equal to y minus 0.5 into x, and dy dt is equal to sine x, and then you decide what is x, minimum y, minimum maximum x, maximum y, and then you click the phase plane plot. You get this type of plot, and if you click on any point, you will get one trajectory. Means in this case, if I start at this, suppose x equal to 0 and y equal to near the 2, I will have this red trajectory which will collapse after spiraling because I have a spiral sink type steady state. We have discussed about spiral sink in one of our lecture. What I am saying here is that just don't blindly follow those lectures. Use these direction field plotter and phase plane plotter, plug those example equations that I have discussed in the lecture and visualize them yourself. Change the equation, see how things change, right? Then the course will be very interesting. Hope you will use it because these are very useful tools. One question is there whether it will be recorded and available later for review. Possibly it will be. If it is, then I'll post a link for that in the discussion forum. Then I have a question. There is a question in your in the YouTube. Will you cover dynamics of CTL response in response to a bacteria or viral interference in spores? Okay, no, we do not have any such particular model because those will not be one dimensional or two dimensional, or that will be actually extremely domain specific, right? But if you are working, this for ASICs, I'm saying, if you are working on dynamical problem in case of immune system, and you have already some model in your hand from literature, right, or textbook, these course, if you go through, then you will be able to understand them yourself. Trust me. There can be edges which some advanced thing which may not find difficult, but the gross, how they write the model, what they are simulating, what analysis they are doing, those things you should be able to understand. If you go through all the lectures in this course, and then if you have this immune response CTA or immune cell dynamics models with you from any paper or any other research article, I assume I can say that you will be able to understand it, right? So the answer is no. We will not discuss any particular model like that. We will discuss mostly on gene regulatory models, right? Then we'll have a couple of cell differentiation models where one cell is differentiating into another type of cell. Those type of models we will discuss, but not this particular. So we are almost nearing the end of our discussion. So if you have any other query, you can ask me. Otherwise, I will go and discuss how should prepare for final exams. Is there any particular question? Second live session we are not sure yet. If there will be any second session, you will get the information. Please, if you have any query, please post the query in discussion. That's very useful. We every day, twice throughout the day, we check the discussion forum. You post your question. We will try to answer. Either me or the TA of this course will answer. Some of you, I have seen over the years, are hesitant to answer right on the. It's fine, I understand. Some will be hesitant. In that case, you can get my email ID anywhere, right? So you drop me email, right? Clearly write your problem that you are facing, or the query that you have. Be assured I'll answer. Right? As long as it is related to this course, I will answer it. Fine. How do you taking value of x in K2 in Runge-Kutta method? I don't have the slide here. What do you mean by K2? I don't remember actually what do you mean by K2. Understand what do you mean by K2 here, right? So it will be better if you can drop the question in the discussion forum in detail so that I can understand what exactly you are asking, right? Jilka Kishan, I'm responding to your question, right? So I don't understand exactly what you mean by the value of X in K2 in Gupta method, something like that. You have asked, right? So please post the question in the discussion forum. You can give me a screenshot of that slides also, where, or if you want, you can post it in the drop me email. I will answer. Right? Okay, so let me go to the last topic. If you are, yes, I understand the Kilka that you are asking about Gupta method. Right now, the slides are not in front of me, so it is difficult for me to answer that particular question. So it will be very helpful for you and everybody else if you post the question properly in the discussion forum, and if possible, give a screenshot of that portion of the slides where we have this K2, right? So then it will be easy for me to answer. So now if I go to the issue of how to prepare the final. As I said, you don't have to go to your library and hunt for books and those. This course is self-sufficient. So follow every lecture and their slides thoroughly. Don't take things granted. If I am saying something, listen to that why I'm saying that. If you cannot understand why I'm saying that, why I'm insisting that this should behave like these variables should behave like these graphs should look like this, you must try yourself. If you cannot understand, post a question to me in discussion forum or through email, right? Understand each and every comma, full stop of this video lecture and their slides. And I guarantee you'll be ready for your final, right? So please go through the video and the slides. Follow. And then in almost all these slides, we have some sort of mathematical problem, some model, some equation. You practice them yourself. Don't watch the videos just like you are watching a second. No, you practice them yourself. You do the problem, solve them. If some integration I'm solving on the video, don't take it granted. You solve yourself, right? And then you learn. So that's very important. Because you can always expect that some problem in exam will be a modification of what we are discussing in the video, right? So if you discuss what we have in the lectures, then we can easily we will be able to answer those questions in exam very easily. Then comes the question of JSON. As I said, that you have to learn JSON, right? You have to learn JSON because the first reason, without simulating a mathematical model, you cannot learn. If you are serious about this course, and if you really want to learn, then you have to see. There are hundreds of simulation tools. If you are very good in programming, you can try a programming language like Biplap, Julia, C, or Python. They have ready-made package for Eulers Method, Gupta methods. You can use them. That's nice, great. But in general, we insist that you also learn JSON. And remember, apart from learning the topic, learning the model, and playing the models in JSON, remember we will have questions based upon JSON in final exam. As I said earlier, you will not perform any simulation there during exam. No, there will be no simulation. You have not to simulate anything using JSON, but there will be questions based upon JSON. For example, as I given the example earlier, you may have some JSON code. I ask you to find the mistake, or I want you to edit that, or I want you to tell me what is the output of that, something, right? Second thing is that please submit all assignments. Every assignment has 10 questions. That does not mean that will be able to answer all 10 questions. But don't stop from submission. You submit whatever you are able to answer. Submit the assignment, because you remember the marks matter. Assignment marks matter. At the same time, go through the solution of the assignments. Try to solve them yourself once you have seen the solution of the assignment. Practice them thoroughly. And before exam, again go through those solutions for assignment. Right? This is very important. You have to solve the problem, discuss in lecture yourself. You have to solve the problem given in the assignment yourself. So that if there is any modification of those problems, you don't get fooled, you don't get scammed. You will be able to answer. Right? So as I said repeatedly, follow the lectures and the slide and the assignment religiously. You will be passing this exam with flying color. I can guarantee. Right? Is there any question about your about the exam, final exam? Please post it either on YouTube or in this discussion forum, because we have a couple of minutes only. So if I understand Jilka Kishan, you want a mathematical reasoning that why those slopes are calculated that way, right? Because I have not shown the details of the mathematics, just I have explained it visually. Right? So, but mathematically, how it can be possible? You have given a screenshot and you are asking that, right? So, what I will do, so I will not post the answer here because I have a textbook which has a section on details of how to do the derivation. Can you please drop me email in my IITG email ID, biplap@iitg.ac.in. You can find it anywhere in the web, right? You drop me email, I'll post it to you. Because I have not discussed the detailed method, mathematical method, because that requires some amount of understanding of Taylor series, which most of the student possibly does not know. So that's why I have not discussed that in the video lecture. I have explained it in the visual form. Okay, fine, I'll do that. I'll send it to you. Fine. Thank you. Any other question? Is there any other question you may ask, because we have just 2 minutes left? Okay, weighted mean is nothing that will be discussed in. I'll share that by textbook link, right? You can read that chapter and understand. Weighted mean is nothing but the when you add two things to multiple things to calculate mean, weighted mean each of them has a weight. Weighted not one, right? That's a weighted mean. Let me share those text file to you. You will be able to understand. If you cannot, then you write me back. Fine. Okay, so if there is no more questions, I hope all of you are going to the lectures. All of you sincerely trying to solve the assignment and submit it. Please submit the assignment, give feedback about the course, and give the final exam. As I have discussed, if you are thoroughly following the videos and slides, you will pass the final exam with flying colors. So thank you for joining today. Have a nice evening and see you on our next live session if we have. If this is available in YouTube in future, I'll post that link in the discussion forum and the portal. Thank you for joining. See you.